First of all, it is amazing to be back here. I've been here in 2016, and you guys were an amazing crowd, so I'm really happy to be here. So let's do it, right? Everyone ready after lunch? Everyone still asleep? Yeah, I love what you call lunch, right? In the Netherlands, lunch is bread with cheese. This is lunch, so it's really good. All right, so let's talk about application metrics. So I just want to get a taste. How many of you actually collect metrics in your applications today? All right. How many of you have dashboards following up on these metrics? Okay, that's less of you. It's still about half. All right. How many of you are here just because of Prometheus? Okay, cool. We'll get there eventually. All right. So let's talk about metrics, because most of you said you are collecting metrics. So I imagine that there is some theory to what you're doing. And if I switch on my clicker and click in the right place, I might actually switch slides. But how is it that you actually do metrics? If you're not thinking about it, you might be... How many of you have seen the movie Prometheus? All right, this is actually what the talk is about, not the other Prometheus? No. In that movie, we see a different idea of scientific process, right? Instead of thinking about what are we going to do, we can just, poke at the little alien thing and see what it does, right? That's hopefully not how you do metrics. Hopefully you think about what you're doing and understand what is it that I actually need to measure. So, I'm Rafael, and I work at Usability. Now, usually I would not stand here and tell you about the great company I work for and that we're hiring and it's great. I wouldn't do that. But today, I need to at least tell you a little bit. Because I want to walk you through what we changed in the past few years and how we got where we are. Usability is a feedback company. Essentially what that means for us to understand here is we allow you to collect feedback from your customers. We receive that data, we process it, and we show you beautiful dashboards. Usability has been around for 10 years, and the code base has been around for 10 years. You can imagine what a code base of 10 years looks like. So we started a big rewrite, a new vision of usability 2 years ago, and this is where this talk comes from. So instead of just telling you about metrics, I'll do it with this as an example, so we can understand the thought process behind starting to do metrics. So what I'm going to tell you about is what we call the pipeline project. Now, the pipeline project is essentially what stands between the feedback that users provide for us and the dashboards that we show. This is a big project. It involves Kafka for events being piped from one part of the system to another, a bunch of microservices. Yes, we do microservices. That apparently is not the best idea in the world, but we have a great team, so we can do it. And I can tell you a whole bunch of other stories about Kafka and PHP, which will raise your hair. So if you want to hear about that, come talk to me after the talk. But cool, so this pipeline essentially is the first step between data coming in and how we get data to the rest of the system. So that's the context of what we're going to be talking about today. So metrics are important because they give you insight into the current state of the application. Right? Metrics are not just numbers, they actually have a really important meaning. Metrics can tell you if your service is healthy. And that's really important. Anyone here doing canary deploys? No? So canary deploys is once you figure out, okay, my service is healthy, I can start moving more people towards it. But if you want to know if your service is healthy or not, you need to have something to measure. Anyone using Kubernetes? A couple of hands, brave people. Do you have an operations team with 5 people? I hope so, because you're going to need a lot of them. But it's a great technology, right? And in deploying things in containers, in Kubernetes, or whatever other technology you're using, you need to understand if your service is healthy, or if you need to spawn a new container, remove that one, and so forth. So understanding if your service is healthy is really important. And then metrics are one of the ways you can do that. Metrics can also tell you what is wrong. Maybe something is broken. Maybe you're not getting the same throughput that you're expecting to get. Data is not getting to your database, right? You can do that, obviously, if you're watching exceptions, which everyone is, you know when something is wrong. But metrics can give you a little bit more subtle information into what's going on. Metrics can also tell you what is right. And that's also good to know, right? You want to know, yeah, okay, I have clients going through my system, and I have data coming through, and everything is working great. But metrics can also help you figure out what will soon be wrong. How many of you are working with Kafka? A couple of you, all right. Kafka is a great technology, but you really need to keep an eye on it. If your consumer lag, if messages are not coming in and not being consumed as fast as you expect, you want to know what's going on before you have delayed all of your customers' data for 5 minutes, an hour, or whatever. So you want to keep a close eye on these things, for example. But metrics will also tell you where to start. Okay, so my service just went down. What happened? How many things are going through my system? Where are they stopping? Where are they accumulating, right? Metrics will give you an idea of where to start digging in. Because we have great logs to dig in afterwards as well, right? We're all doing logging? I'll take that as a yes. Cool. Cool, so metrics will help you do that. Will help you start off that way. So I want to introduce you how to think about metrics. And I got some of these ideas from this book, Site Reliability Engineering. Great book. It was written by a couple of people, more than a couple of people at Google. And it really has some interesting ideas on how they think about metrics. Now, Google is a very big corporation, and it's a great place to learn about new ideas. So in that book, they introduce 3 topics: SLIs, SLOs, and SLAs. How many of you have heard of SLAs, service level agreements? Right? Most of us have heard them. It's where the money starts coming into contact with us. It's like, oh, well, my service has been down for more than 5 hours. I get money back, or I'm going to get sued, whatever. But SLOs and SLIs are are not usually talked about. SLOs and SLIs are what compose up into an SLA. So let's cover each of these. First of all, SLIs. Service level indicators. Now, an indicator is essentially what we call today a metric, right? It's something that you can measure and get an actual number from it. So if I measure the amount of people going through my service right now, so the amount of people online, I get a number, 5. If I measure the time it takes for my page to respond to your request, I get a number, 150, right? That's an SLI. And you want to be able to have many of those. But on top of this, you have SLOs, service level objectives. And that's where it gets interesting, because a number, an SLI is just a number. If you don't give value to the number, it doesn't mean anything. And the objective is exactly that value. Where should that number be? Should it be higher than 150? Should it be lower than 150? Or should it be exactly 150? You need to know what that metric means and what your target is. And that's really interesting, because we think, okay, well, what's that for? Is it for our operations team to know if everything is okay? Is it for the customer? And actually, there's a third part of this, which is really important, which is for you as someone architecting a system. Because if you have an SLO, you know when to stop, right? I mean, we're all developers. We like to optimize everything, right? We want to make sure everything is the fastest, the best, and can do things in the best way that you can imagine. Maybe. How many of you have gone through your code thinking, should I switch my echoes for print? Hopefully none of you. But we like to optimize. But how do we know when to stop? So SLOs can help you with that. And I'll give you an example from our application. So from our application, up front, we understood that one of our SLOs was that our public-facing API, the one that receives the feedback, needed to respond in under 150 milliseconds. Okay, 150 milliseconds with PHP API, easy peasy, we can do that. So we started looking at our stack, and with our regular Symfony stack we had before, we weren't reaching that limit. And one of the things we wanted for the new architecture was to have a slimmer stack. So we rolled out a framework called Chimera PHP, which is essentially a very thin layer of CQRS on top of the Symfony dependency injection container and fast route. So we're like, okay, this is cool. This gives us the architecture that we want. And then we went and we measured our metric. What is the response time we're getting from that? And this was a standard rollout of this framework. We were getting 5-millisecond responses. So then we could make an easy choice. Do we continue trying to optimize this, or do we actually go invest time into the rest of the API? Right? So having that SLO and knowing when you start hitting it can tell you what you need to do. So if with just this change of framework, we already hit that SLO, I don't have to start looking into caching and whatever else I would have to implement on the server to get it to go faster. I'm already under my SLO. So it can tell you when to stop and move on to different things. And then finally, we have SLAs. So as most of you are familiar, service level agreements is the commitment you're making towards your client. So essentially, you're taking your SLO and saying, if I don't hit this SLO, these are the consequences. So if I don't give you 99.999 uptime, I'm going to give you your money back. Or I'm going to give you cookies on the way out. I don't know. Whatever your deal is with your clients. Right? And this is usually not something that developers need to worry about, but we'll talk about it more later. Cool. So now we know the three parts that we need to cover. How do we start picking those metrics? How do we start actually measuring what our system is doing? Cool. Etsy Engineering, a big company in the US. I've got completely messed up in geolocation. It's where Erasmus currently works. And they put up a blog post. And they put up a blog post telling people, okay, how do they think about metrics? And essentially they said, if it moves, we track it. Okay, so the answer to what should I measure is everything. Okay, let's roll with that and let's start exploring that. So metrics kind of divide themselves in two different aspects that you're trying to cover in your system. You've got metrics for telemetry, things that you want to know about the state of the system right now. And you've got statistical metrics, things that you want to observe over time, maybe compare with previous periods, but have a better historical idea. So let me step into each of these. First of all, telemetry. How many of you are Formula 1 fans? Every time I ask, the number gets smaller and smaller. That's fun. But if you've ever seen Formula 1, they do a lot of telemetry. Every car out there on the track has so many sensors on it that the engineers in the factory, all the way back in England or wherever it is the factory is, they get that constant stream of metrics from the car. Now, this is so powerful in Formula 1 that there's actually a rule that the engineer cannot give tips to the driver. Because with this, they're able to tell the driver, you should turn a little bit sharper in this turn to get 5 milliseconds off your time. So it's really powerful in Formula 1, and the same plays for development. It is really powerful for you to know exactly what's going on in your application. Where is the data getting caught up? Where is the data flowing nicely? Where am I getting slow things? You need to understand all of the details, and you want to know them now. These are usually metrics that you care for in that moment, not in the future. You're not going to look back at these metrics like, oh, well, back in 2015, I had one request that had a 150 millisecond response. You don't care. But you want to know right now. This is the stuff that's usually up on your dashboard saying, your systems are good. Relax. You can go home and enjoy your beer on Friday. Or these are the ones that are going to tell you, yeah, no, you're not leaving today. You got a bunch of stuff to fix. Right? On the other hand, you got statistical metrics. Right? So this, keeping with the Formula 1 theme, is like the results from previous seasons, where you can go and say, okay, which one was the driver that actually won? Which one was the driver that was second or third? And this is really good for historical purposes and for comparisons. Because now you can look at that data and say, well, my service is doing well right now, but compared to last month, how am I doing? Maybe now I have an uptick of clients, and I want to make sure my database is responding well. So you can compare that data historically. Go back in time and see how it went. If you go back in time enough, you might actually find a Brazilian who actually won Formula 1. We miss having Ayrton Senna around. But that's the power of statistical analytics, right? You're able to go back in time, compare, understand, and understand the history that led you to where you are, or understand your current metrics based on where they were in the past. Let me see if I can get the bottle open. This is really not good entertainment, I'm sorry. All right, cool. Anyone asleep already? Can you please nudge him to wake him up, whoever's next to him? All right, cool. All right, so we got these two. right? And if we look at the pipeline project, I'll give you a couple of examples from there. We do have some telemetry ideas. All right, so let's go back. I missed half of my slides. That's cool. Anyway, so telemetry. If we look at the pipeline project, some of the telemetry things we have is, for example, the response time of the public endpoints. It's something that we want to know. If at this moment that point is going down, I want to react. I want to spin up more servers. I want to scale up my server base. On the other hand, we also have statistical data. For example, the amount of incoming feedbacks and where they're coming from. I want to understand, is most of my data coming from product A or product B? So we talk about web and app, for example, different origins of feedback for us. I want to know, is 80% of my traffic in web feedback and only 20% in app? What does that mean for me as a developer, and what it will mean for other people, like business, for example? So those are a couple of examples there. Now, let's go back to what Etsy said. Etsy said if it moves, we track it. Now, if we're measuring everything in our systems, can you imagine how many dashboards you're going to have and how you're going to keep track of all that? So there's a lot of stuff you can measure on a server. You can measure system throughput, availability, request latency, error rate, resource usage. But you can also measure the incoming data, the CPU, how is PHP doing, how is Nginx doing. If it's not enough, you can go meta, and then you can measure your metrics to make sure your metrics are metricing correctly. That's a lot of data. That is a lot of metrics, right? And since we work with gathering feedback, I can tell you one thing about humans. If you flood them with information, we shut down, right? When was the last time you picked up a PR to do a code review and it had 3,000 line changes? How long did the code review take you? 2 minutes, yeah? Yeah, right? Too much information. We get lost in that information and we kind of like zone out of it and don't pay attention anymore. Now, if you get a PR with 5 lines, you're going to reach each of those lines and you're going to go, yes, there's a typo in line 2. Right? So too much information overwhelms humans. We cannot take all that information. So we have all these metrics. What do we do? Right? We want to have the metrics, that's really good, but we want to define what metrics are actually our SLIs. Because our SLIs should be a subset of everything we measure. Because different SLIs mean different things to different people. So picking good SLIs is really about understanding that. What do they mean to you? What do they mean to your service? What do they mean to your clients? What do they mean to your business? And they may actually change according to who's looking at that data. As a developer, I care about the throughput of my server. I care about how well that server is doing. As someone in my product team or in business, they might care more about how many clients we have, how many people we have going through the system. Right? So depending who's looking at those metrics, they're going to consider different ones their SLIs. So sure, track everything, but then understand which one of those are your indicators. Because that's the big difference between a metric and an SLI. A metric is a measurement that you're taking. An SLI indicates something to you, so it has value attached to it. And that is something where it's really important for you to understand the nature of your system. Depending on what kind of system you're building, you're going to want to measure different things. So in the book, it defines a couple of ideas of what are systems. For example, user-facing systems. User-facing systems have one set of metrics that are really interesting for them. Things like availability, throughput, latency. You want to know how quickly am I responding to users, because now you're talking directly to your clients. They're having that experience of reading your website. But maybe you have a storage system, like a database. Then you start caring more about the durability, because it turns out that if you send data to a database and it doesn't actually store it, it's not good. Right? So durability is really important for a storage system. On the other hand, you have big data systems where you have lots of data piping through, and then you care a lot more about the throughput of that. How much data can I take? How much data can traverse my system? And what is my end-to-end latency from where it starts to where it ends? So depending on the system you have, you're going to care about different things. We looked at the pipeline, and we concluded that it's a mix of a user-facing system with a big data system. So we have a public endpoint, and we receive a lot of data. Big data. Big data. So how do we measure? What do we measure there? So a couple of examples here is our response time. Response time is really important to us because it's the experience that the user is getting directly from us. The turnaround time, how long does it take for me to receive the feedback and that feedback show up in your dashboard? Or the individual processing per step. Like every time a feedback comes in, we do a bunch of normalization and consolidations and different steps on it. I want to know how long each of these steps are taking so I can know, well, this step is taking too long and it's throwing off my other SLO. Or just counting how many of these things are coming. This was really relevant to us as developers because this, if you're a developer in a DevOps culture, you're on call. Not that other guy sitting in the room or that other girl sitting in the room. It's you. You're on call. So when something goes wrong and you want to see what's going on, you want to look at these metrics and say, aha, I know exactly where the problem is. On the other hand, we have our operations team. Great bunch of fellas. But they care about different things. They care about, is Nginx running well? How's the node statistics? Kubernetes data. They care about the size of the cluster to see if it's not falling over. And they care about if Kafka is actually Kafkaing. These little details. To them, that is way more important than the application metrics that we are serving. So depending who is looking at that data, they're going to get different ideas from it. So make sure you understand also who is your clientele? Who wants to know what is happening with your application? Cool. So once we have those indicators defined, we need to define objectives. Again, if you just have an indicator, it's just a number, it doesn't mean anything to you. The objective will give you meaning. So it can be a target, it can be a single number, it can be a range, whatever it is that describes the optimal way that your thing should be functioning. So first of all, don't pick them based on what you have right now. Right? Because we tend to think, well, we're writing a new system, we should just do what we had in the old system and it should be fine. It's a new system. Look at it as a new system. Understand where the need is coming from. The old system is not your client. Your client is the client. Go talk to the client. Go figure out what experience you're trying to deliver. So one of the examples of this in the pipeline is we're looking at how long should it take between a user clicking OK and the user getting a confirmation that, thank you for your feedback, please enjoy the rest of the day. How long does it take for, what kind of experience does the business want to deliver to these clients? Now, if you ask developers, you'll get one type of answer. If you ask other people, you might get different answers. So we went around and we started asking different people. Some people said, all right, I want that to be immediate. I was like, okay, immediate. Sounds like a good metric. Another team told us, we sell it as real time. Can anyone guess which team that was? Yeah, that's the people who sell the features before we build them. But okay, they're using the word real time. That means something, okay. Then we talked to another team, and they said 500 milliseconds because there's a lot of HTML. And like, okay, that's an engineer. They know too much about this. And then one of them actually said, I have no idea. It was the product team in this case, but But each of these people expressed a different value, right? And it's up to us as developers, together with the product team, ideally, to understand what these mean together. Are we actually doing this in real time? Are we ready to invest what we need to invest to make it real time? So that starts the discussion. You start talking to your team, and you start figuring out, okay, this is what we need, this is what we don't need. So it turns out that we went with the idea of immediate, which to a human being is about 100 milliseconds. So if we do anything above 150 milliseconds, it's no longer feeling like immediate. So we set that as our SLO. Now I'm happy to say that our current measurements are at about 50 milliseconds. So we got quite a margin to get there. But we had that conversation. We explored it. We figured out what we wanted. We figured out what they wanted. And we finally came up with an idea. You want to have SLOs, but you don't want to have too many. If you say, okay, well, I want to take all of these 50 things and I want to make SLOs for them, you now have to keep track of 50 different things. And if they go bad or wrong, they need to be in dashboards. What does that number mean? Otherwise, it becomes background noise. So if you have too many SLOs, it's just too much. Again, humans don't deal well with too much data. So pick the ones that are really core to your business. Understand what it is that you need to do. Obviously, you can have the other metrics there for informational systems, but which are the ones that are going to tell you something? These are the ones you want to be alerting on, right? As soon as one of these goes off, you start getting alerts on Ops Genie or whatever it is you're using. Don't overachieve. Now, this is an interesting story. Developers like to be perfect, but developers are also lazy. So the Chubby system is a system within Google. And it just does something internal, but essentially every system within Google relies on the Chubby system. It sends a request to them for whatever it is that Chubby does. And Chubby has been around for a long time. It's a really stable project, and it had an insane uptime. Like, we're talking above 5 nines of uptime. That sounds great, right? If your system is up for that long, positive, everyone, you want that system? Okay. Turns out that's not good. Because other systems that were relying on Chubby really relied on Chubby. They never planned for outages. I mean, how many of you have fallbacks for AWS S3 going down? Right? It never goes down until it does. And one day, Chubby went down. And half of Google stopped working in horrible ways because everyone relied so much on Chubby because it was always available that they never built fallbacks into the system. No gracious degradation of service. So you're like, okay, interesting. I can see how that happens. Developers tend to get comfortable with things that don't break and just rely on them. So what they did is they took their SLO and they lowered it down to 5 nines in this case. So 5 nines, everyone started looking like, oh, okay, 5 nines, it means Chubby is going to go down every now and then, so maybe I should build some fallbacks. And in order to keep that culture going, whenever Chubby hits more than 5 nines, they actually have planned outages. They will bring Chubby down to keep Chubby at the SLO because it keeps all of the other developers working correctly in their own systems. Blew my mind away, like, okay, you don't want to be perfect? Okay. Could have fooled me. So don't overachieve, you know. Make sure your SLOs are realistic and you understand why you have them, what the value of them are. And continually adapt, right? Your system, your business, everything changes constantly over time. So make sure you evaluate once a year, once every 6 months, depends how quickly your company is moving, reevaluate those metrics. All right, and then finally, SLAs, right? Meeting the expectations and agreeing with the client what it means to miss an SLO. I'm not going to dive into this. You as a developer should not be in charge of this because, you know, this is where you attach the actual money to things, and the night is dark and full of loopholes. Just, you know, talk to legal. If you don't have a legal department, tell them to hire a legal department, but talk to someone from legal. You want someone from legal to help you with this. This is not something a developer should be defining. This should even happen outside of your department, ideally. You just need to make sure your SLOs align with it. And if I can give you at least one tip in this area, define your SLO with a safety margin. So if your SLA says, oh, every time I hit 5 nines, the client will get paid something, then maybe your SLO should be a little bit lower. So if you want to say 150 milliseconds, make your SLO 120, because when your SLO starts failing, you have time before it actually means you're going to get fined by the client. So give yourself some margins so you have some time to react to problems, because turns out problems happen. I swear to you, I've seen them. Cool. And then finally, metrics and practice. So everyone who was here to see Prometheus, I have managed to talk myself into a little bit of time to talk to you about Prometheus. So, why Prometheus? I could have talked to you about any of the other solutions, Graphite, StatsD, so many different ideas out there. Prometheus caught my eye because Prometheus does things slightly different. So Prometheus is essentially a metrics platform. And what it does differently is, if you think about all the other ones, Essentially, you have your servers, and you have that big project over there. Rafael, you're forgetting your talk. So you push metrics, right? You're sending metrics constantly to these other servers, which means if you start adding more servers to your own architecture, you now have a bottleneck over there. So you want to do it asynchronously so it doesn't lose any data along the way. Asynchronous in PHP is fun, not always reliable, so you want to make sure you have a balance there. What Prometheus does differently is it flips that model on its head. You collect the metrics, store them locally, and Prometheus says, I'll come get them. It's fine. So Prometheus will go to your server and do a pull on those metrics. Prometheus does an insane amount of magic on this. It will always pull that data and it will figure out, oh yeah, I already got this, I already got that, sums it together, patches it, and it's beautiful. I have no idea how it does it, but it does it, and it does it pretty well. Now, that's great. It means you don't have to worry about scaling your Prometheus cluster. You just need to tell it how often to come scrape your data. Prometheus is great for telemetry data. Amazing for telemetry data. That's the data that's constant there, always in the moment. Statistical data, not so much. It can have like dropouts every now and then because it's scraping a new service. You can maybe not send all the metrics at a time. So if you want statistical data, you can look at other solutions. You can also use the long-term storage plugin to connect it to things like InfluxDB or StatsD. So it will give you that long-term storage. So if you're using Prometheus for statistical data, you might have some interesting results, some missing data every now and then. So make sure you understand what you need the data for, and if you're not going to be losing any of the depth that you want with it. Prometheus offers 4 types of metrics. So the first one is a counter, which is simple, right? It's either up or up, +1, +5, +10. And there you can use labels. In all of these, you can use labels. I'll talk about them in a little bit. You can also have a histogram, which is more of a time series, great for measuring things like how long your request took, response times, and things like that. Then you got a gauge, and the gauge is simply a counter that can go up and down. Right? So it's a value that you want to know what it is now, but it's not always going to be going up. It can come down. Then you've got the summary. Summary is a little bit harder to explain, and I've not found too many uses for it. But the summary is essentially a histogram that already calculates quantiles. Who does not know what a quantile is? Oh, everyone knows. Cool. You can explain to me later because I have no idea. No, but it's when you're trying to look up, how percentage of your uptime. So 95% of the time, I'm hitting this, 99%. So those are the 95th and the 99th percentiles. Essentially what it does is it internally does a lot of that math for you, so you can easily query that math directly. But if you already have a histogram, you can calculate the same quantiles. You just need to do a little bit of math in the Prometheus DQL. Cool. If you were doing this with PHP, this is one of the best libraries out there. The Jimdo library, it has flaws. It is not perfect, especially around its metrics storage with Redis. There's some dodgy stuff in there, especially if you have multiple instances of your services going around. So you want to be careful with that. But this is what it looks like. So essentially what your code does, it'll call these metrics and will store them locally, usually using something like APCU. So you write that to local storage. And once in a while, then you need to expose a metrics endpoint. And that metrics endpoint essentially outputs the Prometheus text format, and Prometheus will read that data every minute, every second, whenever it is that you configured it to do. So you need to provide not just the data stored locally, but a metrics endpoint over HTTP for Prometheus to do, to read from. All right, what this looks like from code. This is an example of it, and let's break it down a little bit, right? So first thing you want to do is you want to create your adapter. Your adapter is where you're going to be storing that data. It's either Redis or APCU or a couple of other adapters in there. We recently wrote one for file system. I'll explain a little bit more of that later. So that's where data is going to go. Then you want to create your metric. In this case, I'm going to create a histogram metric. Histogram needs first the adapter. Then it needs a metric name, and you want to be very good about how you're giving names to your metrics. If it's a histogram, you usually want to tell in the metric what the measurement is, right? So response time in microseconds, right? Namespace, metric name, some help text that explains a little bit more about what that metrics mean, because then someone is looking at the metric, they can go, oh, okay, cool, I understand what this is. And then you have labels. Labels are really interesting because labels give you a lot of depth into the data, right? If you're looking at data and just measuring how long it took to respond, 150 milliseconds or whatever, you only know that. Do you have a different histogram for each URL, or do you just count them all? Labels is where you can do that. So with labels, you can say, I'm going to add a label that is a status, so 200, 500, and a label that is a URL, /feedback, /metric, /whatever. Which means I'm now counting the response time for all these things, but I can break it down into, well, give me just the response time of my successful endpoints or of my error endpoints. So it gives you a lot of filtering ability. And then finally, you have buckets. Because what Prometheus does is Prometheus will not store the value of your metric. It won't store 151, 154. It will say, well, it was in this bucket, which is things that are higher than 50, things that are higher than 100. So it could be that one measurement falls into a couple of those buckets. It just means it's a lot easier to calculate stuff on the other end. So this is how you define it. Once you start using it, you essentially call the histogram, you call the observe, you tell it how long it took, in this case, 15 milliseconds, and you pass in the label values. Now, this is not terribly intuitive the way the library does it, but essentially you're passing the values of the metrics that we had above, right? So status first, URL second. Not smart. So now you're saying, okay, this was the URL and this was the status. Same thing happens with a counter. Counter is a little bit simpler. Again, you've got the namespace, the metric name, a help text, and the labels. You no longer have buckets because a counter is just going up or down, or up in this case. And to call it, you increment and you pass in again those label values. So here I'm saying I just had a request that it was a 200 to this URL. Done, cool. If I want to increment by 5, for example, I can then use the inc by and do that. Pretty simple. No real magic to it. All right. Timer is weird. Cool. So that's how you do the actual measuring, but we also need to serve this stuff on the metrics endpoint, like we said. So that's what this looks like. Right? This is the endpoint where the data gets pushed out to Prometheus. Again, you want to get the adapter, and with the adapter, what you want to do is you want to create a render, a text formatter, which essentially outputs the Prometheus text format, and it just renders from the adapter collect method. Simple. Nothing much to it. What it looks like is something like this. So here you can see exactly what I mean. It is meant to be human readable and friendly. You can see the namespace of the metric. You can see the name of the metric. And you can see, according to the labels that you have, the measurement that you took. So in this case, as we showed from the example, the counter was incremented for 200 in URL 6 times. Right? Same thing with the histogram, but now you can see the bucket, the bucket measurement that I told you. You can see here again namespace, the metric name, and you see the different buckets. So in the different buckets, you'll see that it changes according to the last one here. So we passed in 15. 15 is higher than 10. So it's lower than infinite. It's lower than 100. It's lower than 50, but it's not lower than 10. So then you get this increment where only these 3 buckets now have a metric. Don't need to know too much about that, but it's always good for debugging. If, for example, now we had a URL that returned 500, you would see another line there with 500 and /URL and the counter for that. Cool. So what does Prometheus does with that? So live demos always fail, but we'll try that again. So I have a repo, which is down there. I'll post the links for everyone afterwards. But in that repo, I have set up what you need. This is the essential setup for Prometheus server with all of these things running, right? So if you just go in there and you do a Docker compose up, it'll run a PHP server, a Prometheus server, and then we can play around with it. So what happens is every time I hit the URL in that app, this one in case, it will generate some random statistics so that we can look at them. Essentially, it runs the same code you just saw on the slides with random numbers and random URLs. And now we can actually play around with this in Prometheus. So this is Prometheus. Hello, Prometheus. Can everyone see in the back? Yes? Yes? Okay, cool. I love this big screen. It's so amazing. And here we can start looking at our metrics. So Prometheus has embedded in it a graphing tool, so we can play around with it a little bit more. And if we scroll down here, we can see that these are the metrics that we just talked about, right? The app count total, the response time, the bucket, the count, and the sum. So I want to look at the count. And if I just execute this with my console here, what you'll see here is exactly what we saw in that text file. You will see the metric with the actual status and URL. You can see that it also adds its own labels, especially if you're running different containers, you want to know these things. So now I can tell you that I've had, the feedback with 500 about 10 times. Okay, cool information. But I don't want to know this. I don't want to be doing math. Math is hard. And I can also see that in a graph. It's like, okay, it's a lot of information. I want to see how many people have been hitting the website. I can do a sum, and now what it will show me then is one metric, right? Like we can see here in the console better, with 97. So that's the sum of all of the times the counter, so it's the overall count of the counter. I'm like, that's not really interesting. I want to know what's happening with my individual URLs. So with the grouping abilities of Prometheus, I can say, I want you to group them by the URL. And if I group them by the URL, we can now see that the feedback URL was hit 45 times, the metrics one was hit 30, and so forth. But yeah, okay, URLs are great, that's fine. I want to know more about the status. How many errors do I have? Apparently, my system is pretty stable. It only had 25 errors. That's stable, right? I guess. So this gives you a lot of ability to work with this data in different ways. You can graph it, and you can go over the last 30 minutes and what happened before, and you see a gap in data because it wasn't running. So you can do a lot of these metrics. You could calculate things like the percentile. So if I go here on this link, this is, for all my successful URLs, the average response time that I'm getting from them. So if you're saying that you want your SLO to be 150 milliseconds in the 99th percentile, then I can now say, look, in the 99th percentile, my average is about 100. So I haven't exceeded that SLO that I set for myself. Cool. So Prometheus can do a lot with these metrics. If I go back to the what we had here, I can also say, well, here's my counter total, but I want to understand what's going on every minute of my server. I can say, I want you to sum the increase, and I'm just asking for the demo to break, and I want you to do it by URL, or actually by status. That's cooler for me. And I want you to look at every, actually not this one, I want you to look at every 5 minutes. This is wrong. There, here. I want you to look at 5 minutes of data. So now, I broke it, because that's what you asked for when you start messing with your demo. There. So now I can see the increment of that data over time, right? So I had lots of errors down here, in minute 34, down at minute 40, 41, I had less errors. So you can see how much the incremental rate. So this can start giving you rates and percentages over time. And if I say, you know what, I actually don't want to hear about anything else, I only want 500s, I can use the curly brace structure here and go 500s. So now I'm telling Prometheus, look, I only want the 500s, and now it gives me a graph just for that. Right? So this graphing is pretty powerful. Gives you a lot of stuff to work with. Let me go back to my doc over here, if I haven't screwed it up. Ooh. That's Bella, that's my dog. Cool. Dogs usually set people at ease, so think about that when you're giving me feedback on joined in. All right, so now that you see the demo, now that you see all these ideas, now that you have all of this monster in your head, it's very important that you need to see the data to act on it, right? So what we did is we used Grafana to give us dashboards on this. So we just talked about the percentiles and all these measurements. This is exactly what this graph shows me. It shows me how many error rates we have, so percentage of errors over all the requests we have, usually 500s. The request per minute over on the corner there, so how many times this feedback is actually, this endpoint is being hit. And then here we can see the median and the percentiles of those. So we can see here, for example, that this is 15 milliseconds. So we're all under our SLOs. This is constantly up on our wall, so we can keep an eye and understand what's going on there. This one also, this is the counter for the feedback coming in. Like I said, Usability has currently 6 products, what we call web passive, active, SDK active and passive, and email and in-page. So now we know, hey, 75% of our traffic comes from our web clients. Interesting to know. We also know when we have peaks. It's also interesting to see how it goes along with which time of the day people like to give more feedback. So we really get a better idea of what's going on in the system at that moment. And that's what metrics are really for, to give you that idea, that comfort of things are going well. But metrics without actionability are useless. You need to understand what the metrics are, what they're measuring, what they should be, and what to do if they're not there. So if it's out of, if it's missing your SLO, whatever, act on it. You need to be able to act on it. As soon as your SLO is being threatened, go figure out what's happening. Are you being DDoSed? Are you just having too many clients? Is your database struggling for memory? What's happening? Why is that SLO reaching a peak limit? Once you have all that information, then you can have a nice and easy life as a developer, no stress, because that's what the developer life should be. Thank you very much.
Great, Rafael. I think we have at least one question for you. Oh, we have 3.
There we go.
I just wanted to say that, did you forget about Slido? But obviously didn't, so fire it well.
All right, let's see this. With file adapter, how much delay you have in your responses, and can you measure the time needed to write in the adapter? Okay, so we created a disk flusher at Usability, because this is all very interesting if you have HTTP endpoints, right? If you essentially have a PHP process that's long running, so a cron job, well, not a cron job, but a service essentially that is running on the CLI, there's no HTTP endpoint. And if you've ever played around with APCU, you will also know that if you write to APCU in the Apache module and you write to APCU from the CLI, those are 2 different APCUs. So how do you measure that? And that's why we introduced the disk flusher. So essentially what we do is we write to a file on the disk that is constantly being rotated in the background, and we have a separate container that loads that same volume so that Prometheus can read it from a node exporter that exposes the metrics. Now, understanding that, we are currently trying to figure out what the impact of that is. This system is going to production, we actually went to production last week. For the first time with the disk metric. So we're now observing. We took good care to make all of this asynchronous. So it tries to do this at the end of the cycle before starting a new cycle of reading. So it does have some impact, but in this case we're consuming data from Kafka with this service, so the impact there is not too much of a problem for us. but I don't have the exact number. If you come talk to me afterwards, I can try and figure out, look at our services and maybe get a better idea. But obviously, yeah, it will have a little bit of an impact in your performance. Cool. Yes, I can spell the name of the CQRS framework. It's called Chimera, CHIMERA PHP on GitHub. I will tweet about it afterwards, so you can just look at my Twitter feed or just bug me about it. It was created by Luis Cobucci, also a Brazilian living in Amsterdam. Really cool system, and I can share you some code and I can share some ideas. Love the system. It's really simple, but really powerful. Can Prometheus notify in critical case? Yes. One of the things that I didn't show in the Prometheus part is that it also has alerts. And with that alert system, I haven't exported too much because that's also part of our operational offering. But with the alert system, it can trigger alerts in Opsgenie, Slack, or whatever. It depends on the adapters you're doing. But it has a whole section of it which is to deal with alerts. Does Prometheus slow down my server? Yes and no. Prometheus does not run on your server, so it will not impact your server in that way. But Prometheus is constantly hitting your API. So you can easily DDoS yourself with Prometheus. You've got to be careful about that. There's plenty of strategies to work with that. If you're doing container-based or if you're doing server-based serving, you can have different Nginx services. So one to serve the Prometheus metrics, one to serve your actual API. You can have different containers. You can use the same, like a different adapter that then tosses the information to a different storage and then read from there. So you can separate where metrics are collected from where metrics are being consumed. There's plenty of ways around that. I don't recommend I do recommend the Redis adapter if you're just running a simple web server and you just want to have the metrics on a different web server. If you have concurrency, so multiple instances of your app and they're all writing to Redis at the same time, the current adapter will break. We haven't had the time to actually go in and contribute a fix to that because we moved on to the disk flusher. But it shouldn't have that much of a big impact. Have you tried Datadog? And if yes, could you compare them? I have not tried them. I have read and I have talked to them. Datadog, much like New Relic, can offer you a lot in that aspect. You need to figure out which one you want. These services also come at a higher cost, especially if you're doing microservices. The New Relic model up to a few months ago was based on how many processors you have. If you're running microservices on Kubernetes, yeah, you got to be a millionaire to pay for that. So it's also a bit of that, try and figure out where things are. All right, can I collect data from Prometheus and show it on my own dashboard? Yes, by all means you can. Prometheus, you can get the graphs straight out of Prometheus here, as we saw. What we actually use is we use Grafana with a Prometheus adapter, so Grafana reads the data from there. So whatever dashboarding solution you have probably already has a Prometheus adapter that can read data from there. Did you consider using monitoring tools like Sysdig and that goes back to the same question. We did consider it in our current pricing model. Prometheus solved it a lot easier for us. And there's a difference, right? Datadog and things like New Relic, they can collect a lot of server metrics automatically. If you are actually measuring, then you're going to have to go into your website and your application and push metrics out anyway, like, oh, this is the counter of feedbacks, this is the counter of response time. So you get some of those things for free in those offerings, but you still have to change your code. In this case, Prometheus was just a better fit for what we were doing, and it was also partly the choice of the operational team when we talked about it. Prometheus CI/CD flow. I'm guessing you're probably asking if this is about building it, making sure the metrics are being pushed out and all that. You can definitely test it. You can definitely test your metrics. Since it's text output, what we actually have within our unit tests, we have a little test helper. You create a memory adapter instead of the APCU, for example. You run your tests, so integration or acceptance tests, and at the end of that, you query the adapter for the data, and you make sure, okay, do I have 5 feedback items in there or whatever? So you can definitely test those to ensure that the metrics are being collected, and I highly recommend that you do, because we're humans, we tend to forget things every now and then. All right, let's see. Got 3 more minutes. Can you use Prometheus to collect personalized data for user? User visit, okay. You can, actually, if you use labels. If you take the user ID of the session ID or whatever traceability ID you have at that moment, you can add that as a label. And then, like I showed in demo, you can then filter out by that ID, and you'll get the metrics just for that. So if you say, yeah, filter out by this ID, it'll then show you, well, there's so many 500s, so many 200s based on this ID, and you can get those same metrics. And the impact of that is going to be the same as everything else, because you're just adding another label to it. Prometheus, JavaScript, PHP, and MSQL. Oh, MSQL, fun times. Is it possible? Yeah, all of these languages have different exporters. Essentially, everything that you're using today has a Prometheus exporter, which means you can collect the performance metrics from MSQL, you can collect the server metrics from JavaScript, your application metrics from Prometheus, from PHP. It just depends on what you're trying to measure, right? You can easily pick up any of these and measure. But if you're going to measure, the amount of feedbacks, you're going to measure that in your PHP server. You're not going to measure that in the SQL. That's probably not where you want to do. You want to look more in the SQL about how many operations are you handling per second. Is the data being durable, and those metrics we talked about, depending on the type of system that you have. How much time did it take to implement Prometheus in your system? Is our monitoring a separate repo? So preparing Prometheus from an infrastructure perspective was not too long. The operations team is responsible for providing those. I think they didn't spend more than a couple of weeks tweaking it and figuring out how to federate the data around. From a implementation perspective in the application, what we do is we work with metrics first. Before a feature comes in and we implement it, we talk with the product owners about what do we want to measure, what are the SLOs, what are the SLIs. So by the time we implement the code, they're already part of our acceptance tests. So that implementation period is short. It's like adding a test for your test, adding a metric for whatever it is. And no, we do not have a separate repo for the metrics. They're coming from within the application. We do have separate repos for managing the Prometheus side. So how many instances of Prometheus, where does it collect data from, how does it collect the data from those places, et cetera, so forth. All right, almost over. Love questions. Is there any difference between Prometheus and Zabbix? I do not know Zabbix. So come tell me about it afterwards. I've never heard about it. If you have StatsD, worth the time to move to Prometheus? Good question. Initially, I would say no, because you already have something running and you're already collecting metrics. It becomes interesting if you're having issues with scaling and getting the data out. Prometheus is just easy from the perspective that it's a pull model. But I wouldn't say, if you already have something working and you're happy with it, Prometheus is hype, but don't do it just because of that. What happens when Prometheus goes down? Does the app still work? Yes. Since Prometheus is the one reading, your app is just writing to your storage locally, so it doesn't care. No problem. When Prometheus comes back online, it'll go read. It may have lost some data. You may have lost the data internally, because you just keep storing the data, right? You don't wipe it. You just keep storing it locally, and Prometheus figures out what the numbers actually mean. It's black magic. I don't understand half of it. But it doesn't care. If Prometheus goes down, you're just going to lose your dashboards, but the application is going to keep going, hopefully, unless it crashes for other reasons, and then you don't know because you don't have metrics. But other than that, it should be fine. You said you could DDoS your app. Is there any reverse HTTP feature? Yes, you can DDoS your app. I have done it, accidentally, which was fun. I do not know about the reverse HTTP features in it. I could probably look a little bit deeper into that, come check out with me, but we haven't had that issue. because we do separate the server that collects our metrics from the one that serves our application. Ooh,
That's it.
I've done it.
Yeah,
All right, thank you very much.